morning, good afternoon, good evening, wherever you are today. Um, you are all welcome to the vector and tensor analysis class. And as a means of introduction, I will be talking about vector and scalar today. And I believe all of us will enjoy the class. Can you all see my screen? So this is the board we'll be using. And like I explained, please write. And as we are working, let's also be on the same page together. So we have here vectors, and scalar. Vector and scalar. So under the vector and scalar, we have, what is vector? A vector is a quantity having both magnitude having both magnitude. Can you hear my voice, please? And direction. Such as displacement, velocity, force, and acceleration. Acceleration. A vector represents, if you have this, for example, you have from point O to point P. So where you see me doing this, talking about vector or talking about A, is a vector represented by an arrow OP. An arrow OP defining the direction, the magnitude of the vector being indicated by the length of the arrow. The tail end O, or the tail end O of the arrow, is called the origin. That is, this is the origin. We say this side is the origin. Or we call it initial point. Initial point. And the terminal point and the initial point of the vector, and the head, which is P, is called the terminal point. Terminal point. Terminal point is called terminal point or terminus. Or terminus. It's called terminal point or terminus. So let's take note of that. Then we have what we call a scalar. Let's look at a scalar. A scalar is also a quantity having magnitude but no direction. E.g., let's look at the mass, length, we have time, we have temperature, and any real number. Any real numbers also part of what we are talking about. So we can look at the components of a vector. You can look at the component of a vector. We can also, from there, it will lead us into some interesting formula. Let's look at the components. Components of a vector. So we have any vector A in 3 dimensions can be represented with initial points. At the origin of a rectangle or rectangular coordinate. Coordinate system. Coordinate system. So in this case now we can have, okay, let's say, don't forget we're talking about 3 dimensions. It can be from here to this point and to this point. We can have this place can call X, this place can call Y, this place can call Z. So in this case now, we have, this is origin. This is the point of origin, right? Remember initial, the way we define the origin before now. And the arrow will show the direction where each of them is actually going. Take, for example, let's say A1, let's say A1I. 3 dimension will start from probably IJK. So we have A1I, but I can join this one, actually join this one. Look at this. This is the arrow. This one is going there. I can join this to this. And this one will meet this at this point. Remember, this arrow is also moving towards this side. So we can call this one J. I can call this one I. We can call this one A2. A2J. And this particular side can call it A3K. So in this case, I have FYZ in this particular figure. Then, if I want to represent them one by one, I can begin to now explain this by saying, let's A1, A2, A3, be the rectangle or be the rectangular coordinate of the terminal point, remember the definition of terminal point, of vector A with initial point at O. Remember, O is the initial point, the way I explained the other time. The vector, this particular vector, the vectors A1I, A2J, and A3K are called the rectangular components. The rectangular component vectors. Or simply component vector. You can call it component vectors of A. In the X, Y, and Z direction. Respectively. So now let's look at the formulas that are responsible for this. We call it the sum. Under the sum of resultant, the sum resultant of A1 I, A2J, and A3K is the vector is so that we can write A1, A equals to A1J, I rather, plus A2J plus A3K. So for the resultant is the absolute value, a kind of determinant. A will now be A absolute value equals to square root of A1 squared plus A2 squared plus A3 squared. And our R will be X1, Xi plus Yj plus Kz, Zk. So when that asks us to calculate the magnitude, this is the magnitude of A. The magnitude of R will be R equals to absolute value of R equals to square root of X squared plus Y squared plus Z squared. If and the scalar field. But let's look at the example. Let's look at the example. Example 1 says, given R1 equals to 3i minus 2j plus k. R2 equals to 2i minus 4j minus 3k. R3 equals to minus I plus 2j plus 2k. The question says, find the magnitude of A. Find the magnitude of A, R3, B, R1 plus R2 plus R3. C, 2R1 minus 3R2 minus 5R3. Are we there? Are we all there, please? Anybody?
Yes, sir.
Okay, good. So now let's solve this problem one after the other. We are given R1, the resultant of R1, R2, R3. So we are to solve them. Remember the formula of, we have the formula that says, let's look at the solution. The solution here says R equals to absolute value of R, which is equal to square root of x squared plus y squared plus z squared. So all I need to do is, for R3, I know A will be, let's solve the R3. A will be absolute value of R3 equals to absolute value of, what's the value for A3? We have it to be minus I1 plus 2j plus 2k. Right. Then we know this is representing x, y, z. That's the meaning. So we can put it here all together by saying, what is the coefficient of I, negative I? Who can tell us? Negative I, What's the coefficient of negative I?
-1.
-1, thank you. So we have -1 squared plus negative, the coefficient of J is what? 2. 2 squared. Then coefficient of Z is what? 2 again. And 2 squared. So at the end of the day, we have what we have here will be square root of 1 plus 4 plus 4, which is equals to square root of 9. At the end of the day, you have it to be 3. So your R3 will be what? 3. The absolute value of R3 is 3, so we have it. So let's look at B. The B says R1 plus R2 plus R3. There's no how you can match these things together immediately. All you need to do is to add them component by component. You have to be careful. Component by component. Take, for example, we have 3I minus 2J plus K plus 2I minus 4J minus 3K. Then plus minus I plus 2J plus 2K. So component by component, let's add all the I together. So how do we do that? Let me take the I here. I is here. 3I. Take another I here. Plus 2I. Another I here. Minus I. So you have the I now. Now let's do the J. The J will be minus 2J minus 4J, then plus 2J. Then you do the last one, K minus 3K plus 2K. You can see component by component. I component, J component, and K component. So we can add all the I. What do we have if we have all the I? 3 plus 2, 5 minus 1, making 4I. Then minus 2J minus 6J, making minus 4K, minus 4J rather. Then this is K minus 2K. This is 0. We put there 0K. Then we can go ahead and solve the problem because the absolute value of R1 plus R2 plus R3 will now be equals to the absolute value of 4I minus 4J plus 0K. Which is the same thing as square root of, you know this one will be 4 squared plus minus 4 squared plus 0 squared. So if you do this one very well, you have square root of 16 plus 16, 32. Because 0 is still 0. You have to break 32 down. You can't give 32 to me as the final answer because you can still reduce, you can still simplify 32. So how do we do that? 16 multiplied by 2 will give us what? Remember from the elementary mathematics, you have 16 multiplied by 2 will give you 32, which is same thing as square root of 16 multiplied by square root of 2, which will give me square root of 16 is 4 square root 2. You can't break 2 again. That's your final answer. Any question? So then the last but not the least, we're given another question to solve, which is we're given to question 3, which is C. Says 2R1 minus 3R2 minus 5R3. So it simply means that multiply each of them with the coefficient you are attached to them. For example, this will be, you first of all resolve this matter before you solve it. So it's going to be 2 into R1, 3I minus 2J plus K minus 3 into 2I minus 4J minus 3K and minus 5 into minus I plus 2J plus 2K. Any question? So from here, we can open the brackets one after the other. 2 multiplied by 3 will give you 6I minus 4J plus 2K minus, still keep your minus the negative there. 3 multiplied by this, you have 6I minus 12J minus 9K. The minus 5I plus 10J plus 10K. So I can now open the brackets one after the other to open with the negative, distribute the negative across. So you have 6I minus 4J plus 2K. Then this negative multiplied by this. I'll call this one plus, then I'll take my negative inside. If I take my negative inside, what do I have? I'll have minus 6I plus 12J plus 9K plus, this will be 5I minus 10KJ plus 10K. So now, remember we did the way we did it the other time, component by component. Let's select all the I. That is, this I to this I. Then this J to this J. Then this K to this K. You can see. So it is very simple. All I need to do is just to create a parenthesis, I, 6I, take another one, minus 6I, then plus 5I. You have to be careful with your sign here. Otherwise, you can miss it. Plus the one of J, minus 4J plus 12J minus 10J plus K, 2K minus 9K or plus 9K plus 10K. So I can match everything together. Minus 6I, 6I minus 6I is 0 plus 5I. We have 5I minus 4J plus 12J will give me 8J. 8J minus 10J will give me minus 2J. If you add everything together here, what do we have? there's the mistake here. Look at this. The negative, when it enter, this one it turns to positive, negative. This one will also turns to negative, please. Take note of that. So when you add everything together, what do you have, please? So you have here, this is 11K minus 10K, we have plus K. So this is the what we are going to use to solve the problem. Then we can solve this one by saying the absolute value of R1, 2R1 minus 3R2 minus 5R3 will also equals to 5I minus 2J plus K. So when we split this one, what do we have? So you're going to have the square root of 5 squared plus minus 2 squared plus 1 squared. What do we have? This is 25 plus 4 plus 1. This is square root of 30. Is it possible to break 30 down? Look at it. So these are the ways to solve some of those problems when we encounter them. Well, let's look at another question. Any question, please? Bukola, any question? Any question? Are we on the same? Are we getting it?
Yes, sir.
Okay, thank you, sir. Okay, let's move on. Let's look at the question 2. This is just a one question we just solved. Let's look at the question 2. Here the question 2 have if R1 equals to 2I minus J plus K, and R2 equals to I plus 3J minus 2K. R3 equals to minus 2I plus J minus 3K. Then R4 equals to 3I plus 2J plus 5K. The question says, find scalar A, B, C such that R4 equals to A R1 plus B R2 plus C R3. So we are asked to find this. So how do we solve this problem? R4 equals to this. Remember, you know your R4. Don't forget. The R4 is here. They now said is equals to this. We should use R4 to define A1, A2, A, B, C. So you can have similar questions during your paper. So let's solve this one. Solution. We require to do the following. R4, remember, R4 is 3I plus 2J plus 5K equals A. What is R1? Substitute your R1 there. To multiply your A will be 2I I minus j plus k. B, we need I plus 3j minus 2k. Then plus C, which is R3, minus 2I plus j minus 3k. So, what do I need to do in this case? All I need to do is just to open the bracket with A, with B, with C. Then collate those brackets, collate those expansion with according to the component. Collate the according to the components. Now let's do it this way so that you understand better. We know this, we have this one in common. Let's keep it somewhere. Then let's distribute A and distribute B and distribute C. Distribution means use it to open the bracket. So if I'm using this to open this bracket, what do I have? According to the height, I will have here 2AI. If I distribute B here, it will be plus BI. If I distribute C here, minus 2CI. I've done the high component. I'll go back and do the one of B component, J components now. We have minus AJ, then plus 3BJ, then plus CJ. You see, everything is in J. The last one, which is K, I have AK minus 2BK, then the last one minus 3CK. Then I can factorize all their components out one after the other. By doing this, 2A plus B minus 2C in bracket I is the component, plus minus A plus 3B minus plus C is J component. Then plus A minus 2B minus 3C is K component. Everything equals to, don't forget, they are all equals to this gentleman. So now, I will not pick them component by component. If I want to pick it by component, if you look at this corresponding equation, we have 3I, 2J. It simply means this is equals to it simply means this 3I is equals to everything in I. It simply means this J is equals to everything is in J. It's equals to this is equals to everything is in K. So that is the meaning. So we are going to write it accordingly now, using equation method to write it. So it will lead us to simultaneous equation. So let's look at it. So it's going to be 2A plus B minus 2C is equals to what? 3. I'll just pick it is equals to 3. You can be asking how, why, what happened? Okay, we can do it this way. If you said 3I, this is I, right? This one go with this. It will remain this. We can use this one. Call this one equation 1. You do the same thing to B. Minus A plus 3B plus C equals to what? 2, equation 2. Then the last one, A minus 2B minus 3C equals to 5, equation 3. So you have it in this way. I believe you still remember. Can we unmute ourselves? Do we still remember simultaneous equation?
Yes, sir.
Good. So if you solve this one simultaneously, I will just give us this. If you solve this one simultaneously, you are going to have your A is equals to, your A will be equals to minus 2, B equals to 1, and C is equals to minus 3. Try and solve it simultaneously, you have this. Then your R4 will be equals to, remember the R4 we are given from day 1. Look at the R4 here, the scalar quantity ABC. We have it. We have to substitute it back to this place. You have to substitute it back here. So we have the R4 to be equals to minus 2R1 plus R2, because it's 1, minus 3R3. Minus 3R3. Therefore, the vector R4 is said to be linearly dependent. You did this in your linear algebra on R1, R2, and R3. On R1, R2, and R3. So, any question? Because of our time, let me give us a tip. Let's quickly solve this one. It's just a simple question, but it will lead us to how to use another formula to solve. We call it, they ask us to look for parallel resultants. Let's look at it. Number 3 says, find a unit vector parallel to the resultant of vector R1 equals to 2i plus 4j minus 5k, R2 equals to I plus 2j plus 3k. Then the resultant in this case will be R equals to R1 plus R2, which is 2i plus 4j minus 5k plus I plus 2j plus 3k. So if you add this together, what do you have? Component by component, you remember? This will give you 3i plus 6j minus 2k. So we can call remember this is our resultant. Let's call this one. This is our resultant, right? So we don't want to solve the resultant. We know what the formula says. R equals to absolute value of R, which is give you 3I plus 6J plus 6J minus 2K. Then we can solve this one by saying we know the formula is square root of what? 3 squared plus 6 squared plus minus 2 squared. When you resolve this one, you have, this is 9. 6 times 6, 36, plus 4, making 49. Square root of 49 will give you 7. Then, the unit, for us to get the unit, you have this formula. Then, a unit vector parallel to R is given as, look at the formula, is given as R divided by absolute value of R. Don't forget, absolute value of R is the one you get to be 7. What is your main R? Your R itself is this. So we can now solve this problem by substituting our R. So we have the R to be 3I plus 6J minus 2K divided by, what is this? This is 7. Any question? Then you have to divide it. So you have to solve this one by saying, which is 3 over 7I plus 6 over 7J minus 2 over 7K. That is the unit vector. Then you have to prove that this unit vector is parallel. That is, they said find the unit vector parallel to resultant. For you to prove that it's parallel to resultant, everything here must equal to 1. How do we do that? We can check. When you check, this one will be, put this one into absolute value. 3 over 7I plus 6 over 7J minus 2 over 7K. If you put them into square root or square in the same vein, you have 3 over 7 squared plus 6 over 7 squared plus minus 2 over 7 squared. If you punch your calculator, the answer will give you 1. Try it. You have 1 into this. Any question? Any question, please? Can I stop sharing?
No question for me.
Okay. Kisley, any question? Oladujoye, any question?
No question, sir.
Oladujoye, are you still there?
No question, sir.
Oh, okay, that's fine. So, I've been